For the LSL assignment, I have created a rocket launch site that is located in West Bedfordia after some reallocation issues we had with the regional administrator. As you can see, the main building is covered by a black box. This black box provides access level security. To access the site, you shall first gather a note card that is provided by the mat, then drag and drop the access note card key. The security will then be disabled and you shall enter the site. Beware, some of the boxes on the floor might kill you. On the first floor we provide a central light switch for the building. It lets you control all the lights. In the control room, as you can see, there's live stock price of bitcoins for the relevant currencies, and also live temperature of Luton in Celsius and Fahrenheit. On your right you can see the control table. In there you have two computers and they're proposed for each of them to generate a token code in order to initialize the launch sequence. This is meant to be done by two people, but I will demonstrate. As you can see, if you press the launch button it asks for a code. The operator 1 token and the operator 2 token together. In order to generate the operator token, the operator needs to enter the password in the char. Once both tokens are generated, we can enter the code and press the launch button. As you can see, the rocket flies up in the air and then returns. Ahaha, much like Elon Musk's rockets. We also have a light control switch to control the lights on this floor. Now heading to the next floor. In here we have some rocket parts that are not used anymore. Beware, some of them are radioactive and might kill you. Now we'll let the creator explain how does the rocket launch site was built.
Okay, so let's go outside. Okay, outside we can see this black box, and this black box works as a force barrier to the building. So this way, when the security is active, no one has access to the building. Let's just demonstrate that. So as you can see, I can't access the building. And in order to have access, I have to have a valid note card, and this valid note card you can get it from the house mat. Okay, and as you can see, that's the note card. And then by dragging and dropping the note card into the to the detector, security detector, when the security note card is valid, then the security system sends a message to the cube in order to become a phantom, and I will show you that on the code. So basically, so we have the house mat and this code. Okay, so in here we define our events like state entry, sensor, touch start. Okay, so the state entry, this is an event that occurs when the object gets loaded in the sim, and basically we are setting or when the script gets executed in the environment, in the open sim. And in here we just set the text that appears on the actual object on top of it, so get your access key. In here we initialize the sensor. Okay, so basically we are saying that whenever this script starts running, which is when the state entry event gets executed, then we create a sensor that starts sensing on a 40-meter radius, and is sensing any avatar that comes in here. And when that event happens, then the sensor, this sensor code gets executed. Okay, so we have the event sensor is called, and we count how many times was it detected, and then we just go through while it is detected, and it decreases the number of detected. Let's send a message on the channel 0 and we say, hey, how are you? And we detect the name, or we get the name of the detected avatar, and we ask him, would you like to visit this missile launch site? Come and try for yourself. And also we set the event on touch start, so basically this event will get executed when the user presses the mat, and what this will do is it will give to the user, to the detected user, it will give him the item on the object that contains this script. It will give the note card that the object that contains this script. So let's show you. So let's show you, how is it? Okay, so yeah, sorry. So in here, as you can see, there's a silo key pass, and this is the inventory note card. It's the note card that will be given to the user. Okay, so that's it about this one. Okay, so it has a sensors for people around. It sends a message. It has the event touch start that gets executed when the user clicks, and we also have the event state entry, which is when the script starts running on the open sim. Okay, then we can see So and so we drag and drop the node card to this security system, and what does it happen? So okay, so we have a method here that was found online. This is to generate a random integer number. It uses the LL friend, and this is kind of a random number in LSL. Okay, so this generates a random number. And here we define what is the query handler. So basically we keep track what is the query that we did to the data server. But so basically in here the state entry, once again, when it initializes, it sets the text to the object. And then we have in here, so touch start. This event gets triggered when the user interacts by clicking on the object, by clicking on it. And what this does is this basically sends a message on the channel 0 saying close, and the box, so the cube security, will be listening for that. Okay, so basically in here we have in here the cube, and when the cube receives a message saying either open or close, basically what that does is sets the prim to true or false, so lets the user walk into the building or stops the user from walking into the building. And so in here, when you touch the object, it just sends the message to the cube. The cube then executes this method, which will turn the prim to non-phantom, which will be an object that we can't walk through. Okay, and then so our sensor here is as event that is listening for changes. So whenever something in this object changes, so on the node card key, whenever something in this object changes, we check if there's changes in the inventory, and we also check if there's a node card available. So the user just dropped something, and this event gets altered because the inventory on the object increases. So this event gets called by the OpenSIM, and basically in here what we do is, well, we obviously check if there were changes, if there's a node card in, so we don't get errors. We then say that the line to read is the number 5, and this is just for the reason that we only want to read this, which is the actual key inside of the code. And if you see here, we have 0, 1, 2, 3, 4, 5. So it's the 5th line that we want to read, so to check if the key code is actually valid or not. Okay, so that's the line to read. And so what do we do in here? So we call this function ll get node card line, and this function then basically triggers a data server event, and that's this event basically. And we store the ID of this event, so we then can compare if the actual event that is triggering the data server is actually matching the ID that we got when we created this call onto the server. Okay, and then in here we just check if we are not in the end of the file, and then we check if the line on the note card that we just received contains the same content on the line 5, so Ricardo Ribeiro property. And if it does, then sends a message on the channel 0 to open, and it also says valid access card, so the user knows that it has a valid access card. And if the user has a valid one, then it will get that message, and the message will be sent on channel 0 as well, saying close, which then, as I explained, the cube will just activate the security and not let the users go through. Okay. So now if we walk in the house, we have these cubes. Okay, and these boxes on the floor, you have to be aware with them, because if you walk through them, they will kill you. So basically they are like a landmine, we can say. They are left in here randomly, so we increase a bit more the security, and why not? It's always fun to play with lives. So in here we have the on-res event. This event gets executed when the OpenSIM is first launching, like the server is starting. It calls this event on res, so on resolution. Basically what we are saying is we are setting to this box to have a damage of 100. So it will take 100 damage of the avatars, therefore he will die if he walks against it. Okay. Then this button downstairs controls all the lights in the building, basically by sending a message to that all these lights in the building are listening to. And I can show you here. So the full light control is basically, we have a toggle, so it starts on 0, all the lights are off in the first state. We say in here we have a state entry event which gets executed when the server, when the object is loaded, and it just sets the text on the object. Then we have a touch start event. Okay, and this basically is event that gets triggered when the user presses the object, so it acts like a button. And then in here we kind of define two states, which is so we have a toggle which is 0 or 1, and determined in memory whatever this toggle value is, it will either turn on or off the lights, or in this case it will send a message on the line 100, so on the channel 100, either saying lights on all off or lines off all. Therefore it will turn them off, because they will be listening to that message. So as you can see here, so we have a state entry. In this state entry we start listening for incoming messages, so as soon as we put this script on the object it will start listening, okay, to messages. And basically in here we whenever the listen event gets triggered, so whenever a message gets dispatched for this, we will check if it was the full switch, and if it was the full switch, and if it says off all, then we will just stop glowing on the image. Or if it was on, then it will start glow on all the sides of the light bulb. And this is for this light bulb, and for that light bulb they work exactly the same, as you can see, exactly the same code. Okay, now if we add to the second floor, so we could use that, but there's no need, it's a bit laggy. Okay, in here we can see we have livestock Bitcoin conversion, so to what is the value of Bitcoin in GBP, USD and euros, and the value of one Bitcoin, come on, is 631 GBP. And don't forget, we are in a virtual environment. Why not having the future currency values in live data? And okay, so in here we have some tricks. We have to say we have a function in here which was created by Rick. It was found online on the LSL website, and basically what it does, it looks up for a string within a string. So basically looking for a needle in a haystack. So you have a piece of text, okay, and it has that piece of text, and it will check what are the positions, and then when we actually find the string that we inputted to look for, we will get the value or the string back. Okay, so we have on state entry, so state entry gets called when the server starts, and in here we start a HTTP request. Okay, so whenever this code loads, it will make HTTP request to this URL, api.coindex.com, and basically this will give us the live values for the Bitcoin. And I can show you here how do we get the content. The content comes as a JSON, and the server doesn't provide a JSON tracer, so I had to basically use that function that looks a string within a string, and then look within that string for keywords, so I can break it through, like GBP. Where's GBP? Okay, it's here. Then after that, get me everything and look where the rate is. Okay, we look where the rate is, and then we get that value. Okay, and we store it, and then we do it again for the next one, which is US dollar, and so on. So we go and we retrieve this rate, and this rate, just by jumping by keyword to keyword until we get to the right part of the string. Okay, and that's how that does it. And basically it sends a message on the line, on the channel 101, and this is what is going to get printed then on that set text, and that happens in the linked, which has the vortex. Okay, and this vortex is once again listening for message on the channel 101. It counts the lines, so it puts it in a way pretty in the display. It counts the lines, so it knows where it, in what position it's putting, and it sets the text based on the messages that are sent from the actual board that gets the values from the BTC or the script. So, and this works by doing a HTTP request. So HTTP request is a function, we call it on the server, and whenever this function finishes on the server, then it will trigger event which is the HTTP response, and then we check if the request that we are getting, this event HTTP response, is actually the one that we created, and then from there we use the function to look in the string of strings. We'll look for the values of the Bitcoin, and we send message by message to the board text so it appears on display. And this is how the temperature board works as well. So it works very similarly, although on this one we retrieve the weather, and in here we still use this function to get a string within a string. And in here what we do is, so we have the state entry, we define the state entry to do HTTP request to the Yahoo APIs, so we get the weather in Luton. I can show you the data that is retrieved in here. So it retrieves a JSON object as well, and the same way we've done it for the Bitcoin, it's also done in here. So when you touch it, it does a new request, or when the script starts running, it does the request, and this request then triggers a response, which is this event. We check if the event matches the one that we create with the request, and then we just send a message to the 102 with the actual temperature. The temperature is retrieved in Fahrenheit, unfortunately, so we first convert it to Celsius by doing -32 times 5 divided by 9, as it's in here, and we get the Celsius temperature, and then we can just use the value that we have in the mass string, and that is the Fahrenheit value that we receive. And we just send that to the board text script on this one, which is exactly the same one, that one. Okay. Now, if I continue, then we have the control room. Okay, and in here it starts getting a bit more complicated. So in here we have a simulation of like a lunch room, a lunch system, rocket system, and basically we have two computers which are meant to be used by two operators, and these two operators would have a key that they would know, and each one of them would enter that key in each one of the systems, and when he does so, he clicks on it, he starts talking with the terminal, and it says, please enter the access code 1. And we have the code in here as a demo so everyone can try it. You just copy this code and you enter the code into the terminal. Okay, and what happens in here? So this generates a code, which is this token. So this machine generated this token. This machine generates this code token and sends a message to the launch system. The same thing happens with the second operator. So we click on it, it starts talking, we reply with this demo password, and it will generate another token. So now we have two tokens. We have this token for the operator 1, and we have the token for the operator 2. Now if we click on the control launch button, we will see, in order to initialize the launch sequence, both operator keys need to be provided as 1. Enter the code and try again. Okay, so the 2 operator keys need to be provided so we can launch the rocket. Okay, so we have both of them. So we have the first generation code for the operator 1, so we use that one. Okay, and then we combine it with the second token, and now we have the 2 tokens, and we send this message to the system. Now if we click on the button, the rocket is ready to go, right? So he's listening for a specific message that the launch control system sends, which will be launch, and it will send it in the air. So if I press now, it checks that code, and here he goes, he went already. So as you can see, it will be going up, and then descending, much like Elon Musk's rockets. As you can see, it went up and down perfectly. Okay, so let's explain how does this all work. So let's see, in this terminal we have the token generator 1, and both terminals are exactly the same. They have a specific code that they check to. When they receive that code, they generate a token. That token is then sent to the launch system, and whenever both codes are combined and sent through the chat, and you press the button, then the launching starts and it goes up, the rocket goes up in the air, it comes down. And how does this work? Okay, so state entry, this event happens when it starts executing the script. It sets the text to the terminal. Then we have the touch start event, which just prints some information to the user. So we ask to enter the access code, but we also give them the access code. We also register a listener on the channel 0 for any incoming message. And then whenever this listen event gets triggered, so this method, this event gets executed, and basically we check if the message that we receive on the channel is a valid operator key code, which we define up here to be this one, the one we provide to the user basically. And if it is, then we call, we do this calculation to generate kind of a random number, and this random number gets printed on the terminal for the user, okay, and it also gets sent on the channel 510, and that is the code that will be generated, and it will be sent to the start launch sequence. And so that means that the start launch sequence will be listening, okay, so as you can see, the launch sequence will be listening from the operator, either 1 or the operator 2, for the key to come, and whenever those keys come, they get stored on this object memory, okay, and we are also listening for the junction of both keys. So whenever both operators enter the key, so we store that entered password, so then we can execute the launch and check the password entered when the user actually presses the red button to start the sequence. So this one, so the token generation sends a message. This one is listening for the message of the operator 1 and the operator 2, and the operator 2, which has exactly the same code as the operator 1, just with different password. Okay, so let's explain this start launch sequence a bit better. Okay, so what happens in here? We have our state entry. Our state entry sets the text on the object, hovering on the object. We also start listening on the port 100 on the channel 510. This channel, and we listen for two specific objects talking, which is the operator 1 and the operator 2. And so we start listening for this. So we are actually listening for that machine and that machine to send the generated token. And when it does, this knows what is the generated tokens. And whenever the user enters those generated tokens both together, then this can check and execute the launch. So when the machine starts, when the script starts executing, calls the event, this gets executed as state entry event. Then we define the event on touch. Whenever the user touches the button, what happens? So we check if we have a stored user pass, and if that stored user pass is actually equal to the junction of both key passes of each operator. And if it is, then we send a message on the channel 0, sending launch. And I know it's on channel 0, anyone can type launch, but for purposes of simulation, it's always easy to have easy way to just launch the rocket. Okay, and then so in here we are listening for messages that we receive from each one of the machines, each one of the operator terminals. They get stored in memory. We also listen for the junction of 2, and whenever we receive those 2, then we send on the channel a message on the channel 0 saying launch. And obviously the rocket then will be listening. So the rocket is listening, as you can see, for a message from the start sequence button. So is listening for messages incoming from the start sequence button, and whenever the message is launch, we also print on the console saying launch, and then we set the variable animate to 1 and the counter to 0. What does this do? Well, we have a timer event, and this timer event so whenever we receive the launch message, we start a timer event on this object, and we have an animation gap, which is the interval. This is not really real because it will be as much as the server can cope with, not that real value. I would say it's up to 1 second, one second, that the timer gets actually triggered, the event timer. Okay, and in this event timer, so this basically is a on timer, but it's a kind of on tick. So whenever a timer clock does tick, 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 then it will run this event. And basically in here we in each tick we add 1 to the counter. Basically we then set the counter to 0, so we always force it to only do 20 movements up. So we set the position by getting the position and adding 5, and we do this 20 times. So it goes up in the air and then eventually comes down, because we then force it to come down all the way. If the counter is up to after 21, because we also want the animation to stop, because if not we would lose the object in the sky and it would just disappear or have a very weird Z and be difficult to find. So it goes up and then it goes down and stops the animation, and it stays there until it gets another launch message, so it then goes up and down again. In here we also provide the light switch, and this light switch is basically sending, so it sets on state entry when it starts, it sets the text on it, and this one only controls these lights on this floor, not all the lights in the building, but it works very much the same way. It sends a message on 100 and says lights second floor off or on, exactly the same procedure as before. The lights will be listening for it, as you can see in here. It's a bit tricky to walk inside this, but as you can see there, we have the light bulb, so it either receives messages from lights off all, so it turns off when downstairs is pressed, and also when the lights when the switch from the second floor are pressed, it receives that message, and the event listen gets triggered and it turns on or off the glow on the object. Then finally on this floor we have some radioactive parts, so these are some objects from different attempts of building a rocket. It takes more than one iteration, and in here we have some radioactive engine, and basically it's just like the landmine. You step on it and you are dead, because why not having radioactive engines? Come on. We have a super black force field in here as well. Why not? That's it, and as you can see you also have the last floor. We don't have anything on it. It's just some small rockets that I was trying out, and the big rocket. So if you can bring some friends to the launch site, launch it downstairs, and have some of them looking up here, and it will be a pretty good simulation of what Elon Musk does. It goes up, it comes down, exactly in the same position. And I would say that's it for LSL. It was a very funny experience, and we can learn a lot doing event-based and this 3D modeling. It's a really good way of approaching.